afternoon, everyone. Hope everyone can hear me well. My name is Aisha Latta, and thank you so much for joining us for the online Minerals to Metals Forum hosted by the Southern African Institute for Mining and Metallurgy. So today we're going to speak about South Africa's economy gauged in megatonnes, high on extraction, low in stock building, and pockets of circularity. I'm very pleased to introduce both of our presenters today. With us, we have Dr. Willi Haas, who is a senior scientist and lecturer at the Institute of Social Ecology, University of Natural Resources and Life Sciences at Vienna. He has an interdisciplinary background as he graduated as a mechanical engineer and obtained his doctorate in philosophy, subject sociology. He investigates society-nature interactions across time and space and draws insights on the transition from agrarian to industrial societies for a better understanding of the option space for the next transition to a post-fossil society. From a fundamental perspective, he studies the transformation of labor in socio-ecological transitions, as labor plays a key role in the societal metabolism. He is the author of several publications discussing the potentials and limits of the circular economy, and was commissioned as an expert for the European Commission on the topic of material flows in the circular economy. Further, he was the co-chair and project leader at the APCC Austrian Special Report on Health, Demography, and Climate Change, and headed several studies in the interface of health and climate. Previously, he was a public official at the Ministry of Social Affairs, Vienna, director of the Institute of Applied Ecology, Vienna, and acting director of the Environmental Monitoring Group in Cape Town, and a researcher at the International Institute of Applied Systems Analysis. With him, we have Professor Harro von Blotnittz. Harro is a professor at the Faculty of Engineering and Built Environment at the University of Cape Town. He defines his research and teaching interests by multiple challenges of sustainable development in developing country settings. Professor von Blotnittz holds a BSc in Chemical Engineering from UCT, a BSc Honours in Operations Research from UNISA, and an MSc in Engineering from UCT, as well as a doctorate in engineering from the RWTH Aachen in Germany. He leads research in energy and industrial systems analysis and is registered as a professional engineer with the Engineering Council of South Africa. He has published widely in the fields of life cycle assessment, renewable energy, biogas, biodiesel, and bioethanol, and waste management, thanks to extensive supervision of postgraduate students researching these topics. Many of his graduates have gone on to practice as knowledge providers in the emerging green economy. Thank you so much to both of you for joining us today, and I look forward to the session. I'm going to be handing over to Willi Haas for the first session. Thank you. Oh, you're muted, Willi, sorry.
Okay.
Perfect.
Hello.
Hi.
Welcome. Thank you very much for this opportunity to present here and to be together with you, at least in this virtual room. It would be nice to see you, but I think we have to wait for this. Yeah, we are talking now about South Africa's economy, and we look into the economy in physical terms, so not in monetary terms, but in physical terms. And we want to look how the economy behaves in terms of its circularity. And the presentation will be done by myself and Harro. Maybe Harro, you say hi.
Good afternoon, and I'm just looking through the attendance list, and many of you, we know each other, so nice to have the chance to present this work today with Willi.
Yeah, and the work we are presenting here is a product of a teamwork, and I just want to mention Doris Wirk and Dominik Wiedenhofer as key contributors. Yeah, and I think about the funding we will tell you at the end. I just want to step into the issue so that we have enough time for our key aspects of this presentation. So we want to give a bit the methodological background. What is the view, how we look at the economy, how this can be understood. Then we want to focus on the results for South Africa and present you Sankey, so flow diagrams for four material categories and for an interlinked metal complex. And when we have done this, then we look into the state of the circularity in South Africa, look at rates, look at barriers and potentials in South Africa from this really satellite view of the country, and make a cross-country comparison. And finally, we relate the export of the extractives, which characterizes the economy, to circularity considerations. Yeah, and just want to briefly start with this very simple thing about an organism that has a metabolism. And this means that the organism has an intake of nutrients, which is material and at the same time energy, to live, grow, and reproduce itself. And this is called metabolism. And everything that goes in might result in an increase of the body mass, or in outflows like solid, liquid, or gaseous outflows. And in order to be able to do that, you need a source and you need a sink. So a source for taking in and a sink for releasing the outflows. And what's important to this is that's a mass balanced kind of perspective. So everything that goes in needs to be either an outflow or something that increases the body mass. And if we apply this very simple kind of view on South Africa, we can see here a socioeconomic system. So we focus on the socioeconomic system, the country, and what it imports, what it extracts, and what it exports, and what are the outflows to the domestic environment, and both to the global environment. And now it's a white box. I would like to say black box. And if we look into it, we can see here certain processes going on, and these processes are determined by stocks. We call that stocks. And the one important stock, this is the main reason for our societal metabolism, is the population. On a global level, we counted them, and there are 0.2 gigatons. This gigatons is very difficult to comprehend, but in comparison to the livestock, it's half of the livestock on Earth. And when we look into the artifacts we have, what's around here, roads, buildings, factories, electricity grids, and so on, these are on a global level 1,000 gigatons. So these are the stocks that need the flows for operation, for maintenance, and maybe for extension of stocks. And of course, we can take the flows from the environment or from imports, but we can also try to reuse and recycle material. And this is the issue that we would like to focus on. And again, we have a mass balanced system. So everything that goes in needs to be used for a net stock extension, or becomes an outflow to nature. When we look into this a bit more detailed and closer to the way how we have compiled our data, so we have again the inputs, and there we can make a difference between the renewables and non-renewables, and we can look into that, what comes from imports and deduct the exports already in the extraction. And together with what we cycle, we call that processed material. So that is the material that is processed in South Africa. And then we distinguish that these materials might be used for energy purposes, like fossil fuels or food or feed. When people eat something, that's a kind of energy use of biomass, or for material that is used for its material use. And this might become stock building, for example, when we build a house, or when we have throughput materials that might be packaging or something like that, or losses during the manufacturing process. And some parts have emissions and vapor. For example, when we produce bricks, we have vapor, or when we produce steel or concrete, we have emissions that are not energy-based, but that come directly from the material. And this we account for. And then we have, after stocks are demolished, we call something that is in an interim output. That is the material before we decide if we release it to nature or we recycle it. So processed materials and interim outputs are very important indicators for us. And then there are the outputs. So it's emission, solid and liquid outputs, and water and vapor. And of course, when we give something back to nature, there is renewable material, and this renewable material might be, so to say, digested by ecosystems and contribute to new plant growth. When it comes to indicators, we take the processed material and compare to the processed materials what is circulated. So what is the socioeconomic cycling, and when we look to biomass, what is the ecological cycling, and that we can relate on the one hand to the processed material on the input side, or we can relate it to the output side, to the interim outputs. And the main difference between the two is that the interim outputs are the processed materials minus what is a net addition to stocks. Yeah, and this is the principal view, how we look at it. Just maybe for some of you, the terminology might not be so familiar. So we use the word domestic extraction, and this is from mining, farming, forestry, fishing within South African borders. And for example, when we look into agricultural extraction, we look only at what gets harvested. And when we look at extractive waste, this is part of the domestic extraction. And the extractive waste is when we have ores that are removed from the mine, and after that, in further processing, there are tailings and slags that might occur. So everything that is not pure metal is then the extractive waste. Everything that is in the ore, not pure metal, is extractive waste. Of course, there's unused extraction we do not account for. That's material moved but not processed. So if we have a mine and we just want to get to the ores and remove overburden, for example, from one place to the other one, that is not accounted for in our framework. Then we have metal flows, accounts for the element only. So this is the pure metal. Then we have processed materials, that's the domestic extraction plus the imports minus the exports plus the secondary material. So that's the difference to the domestic material consumption. And then there's non-metallic minerals, that's industrial minerals and construction minerals. So it's from sand and gravel, different types of salts. And then we have stock building materials that are the products that stay in use for longer than a year. So everything that is there a bit longer lasting, we account for that. And because our whole accounting framework is done in a way that we always look into 1 year and the materials that are processed within a year. Okay, and yeah, I jumped over one slide. And just very briefly, these are the main sources we were using, and the philosophy in principle was that we use as many national statistics sources as possible, and where we do not have others, we have international sources we used. In practice, we did it the other way around. We used the international sources, and then as soon as we found a national one, we replaced it by these ones. Okay, maybe we can come back to this later if there are any specific questions on specific issues. So now let's come to the results. What have we, with this kind of view on the South African economy, on the physical economy, what was our kind of picture, what we could find? And we prepared this Sankey diagram, and these are the flows through the society. And you can see here the extraction is about 875 megatonnes. These are million tons. And the imports are 32 tons. And if you look into the rough kind of proportions in what kind of material categories came in, you can see 70% were biomass, then the pure metals are 7% of extraction, 23% are extractive wastes, 17% are construction minerals and industrial minerals, 30% are fossil fuels, and 6% are extractive waste related to the fossil fuels. When we go further, we can see the imports. There's a huge part that is oil that has been imported. The exports, before I come to the processed material, the exports, you can see there is mainly metals exported and fossil fuels, the coal. And then you can see this ends up in 760 megatonnes processed material in South Africa, of which roughly half, a bit less than half, is energy use, and the other, a bit more than half, is material use. Of this, about a quarter becomes added to stocks. The energy is mainly the coal burned in plants and the oil in for transport and other equipment. And when it comes to the interim output, we have about 630 megatonnes. So you can see that a lot of what comes in becomes interim output, and that's mainly the fossil fuels burned, the biomass, and maybe just this one word, the fossil fuels burned are here represented only as the part of the material that was in the extractive material. So the oxygen taken from air is not included here. If we would do that, it would obviously almost triple this orange part of the bar. Yeah, when it comes to reuse and recycling, you can see here that in the reuse, but we will go into more detail a bit later. We have here construction minerals as one big part, and when it comes to recycling, of course, the metals play an important role here. And then emissions are very clear. Most of them are coming from the fossil fuels. And when we look into the solid and liquid outputs, they are dominated by the extractive waste from the mining sector. So this is now the overall rough picture. And we can now go into the different material categories. And Harro, please proceed.
Thank you very, very much, Willi. So yeah, those who know me know that my work in industrial ecology has been dominated by life cycle assessment work for a long time. I have done a bit of material flow analysis work before, but this project that we've been doing since the beginning of last year has really been a chance to work with some of the best minds globally in material flow analysis. And I hope I've learned the language properly. So very quickly, a look at biomass, which is not the main focus today because we're speaking to a crowd that is mining oriented. Most of the biomass that we extract in this country and use is for food or feed, so that's energetic use. There's almost 50 million tons of grazing, for example, that's part of the domestic extraction. And there's a little bit that goes through to stock add, that would be construction timber, and some of that even in the mining sector, I would think. A little bit of recycling, that is probably paper recycling, a little bit of maybe construction timber that gets a second life too. And I think we'll leave it at that for the biomass because that's not our main focus today. Yeah, then the non-metallic minerals, which does interest mining folk, that is to quite an extent dominated by materials that go into stock building, so construction minerals, that make cement, for example, and then the concrete that's made with the cement. So sand and gravel is a topic that occupied us for a while. The industry and official statistics in South Africa are lower than what we found in an international source. We were tending to go with the local numbers because we think the Minerals Council might know this correctly, or the South African government. But when we tried to mass balance the recipes to make concrete, we found there wasn't enough sand and gravel in the statistics to use all the cement that is apparently sold locally. So we reverted to the higher number for sand and gravel extraction. There is a stream that goes through to dissipative use, and that includes things like fertilizer minerals, other industrial chemicals that are short-lived, acids and bases and kind of thing. And we also scratched our heads a little bit about the gravel roads in South Africa, which have construction minerals, but when you drive on them, you can see them going up in the air in a big dust kind of plume behind your car. So there's a bit of dissipation that happens with that type of construction minerals. We had no idea really how much it would be, but one has to make estimates because 0 is not a good number in this game. Let's go to the next one. Fossil-based material flows, I think not a big surprise there, really dominated by domestic extraction of coal and the associated coal waste, but also, and the exports of coal, that is a significant export earner. I like to say we export coal so we can import oil whilst we have a lot of sunshine. So there's a big transition that's coming our way there. And yeah, then we see from the coal use, the solid materials, the ashes. We have almost 50 million tons of coal ash of various sorts that add to the extractive waste from coal mining. And there's about 4 million tons of coal ash that actually get reused. So that is the reuse or the recycling stream that you can see there. And I think that's enough on the fossil materials. And then metal flows. Here we have a big dark blue a stream going straight through, and this is really the extractive waste that's associated with our minerals. Our exports are estimated at 54 million tons of in pure metal terms, plus associated with it 32 million tons of oxygen, sulfur, and other gang materials that might still be on the mineral or the concentrates that we send out. But the bulk of the extractive waste remains in the country and often remains obviously close to the mine site or the concentrator. And that, of course, is in addition to an unquantified amount of unused extraction, as Willi explained earlier. We do see post-use recycling. So the stock add of 7 million tons, that's mainly steel, we think 85%, and then aluminium and copper would be the next two big ones. And then the recycling of the order of 3 million tons, just rounded to a single number here. And let's take a closer look at the metal. So the metal accounting turned out to be a little bit of a challenge to our team. because Willi and his group had done these kind of things mainly for what one might call consuming countries thus far, not so much producing countries. And yeah, we then found that it's not as simple as that one line in the spreadsheet is one mining sector that makes one product. You have a mining sector like PGM that has a whole number of different products. It has a chromite concentrate, which in turn is iron and chromium. It has a precious metal concentrate, which is what the business is about. But it also has base metal concentrates, which then again make copper, cobalt, and nickel products. And there's even gold that also comes out as a byproduct. So the accounting became a little bit tricky, and we had to enhance the methods. So a bit of a method contribution maybe to the field of MFA that's been happening here. And we decided to go in a bit of depth on just one set of metals, which are the ferrous metals, iron and steel and associated metals. And here's a Sankey diagram that shows the extraction then of iron ore, which is the dominant one, plus chromite and manganese ores, and how much of that goes to exports. Again, that's in pure metal terms. And then the local steel manufacturing sectors, which are both carbon and stainless steels, of course. We have a bit of the extractive waste then in the orange associated with, so there's some iron that actually is part of the extractive waste but doesn't become steel, goes through. And then we have the steel making, and the dark blue then is the technical material steel and its recycling. Yeah, so that's just something new where we try to actually show how these metals travel together or how they're fused in. And I'll come back to some of these later on around the question of local beneficiation versus export, which moves a lot of debates in the sector. Really, I think that's my contribution for now, because now we go to some of the findings. And that's back to you.
Okay, thank you, Harro. Yeah, our findings for discussion. I mean, when we look into socioeconomic cycling, so for now we leave the biomass or the ecological cycling out of our scope, then we can see here the processed material is 760 gigatons, and we can see that the recycling makes up about 11 and the reuse about 3 megatons. Did I say gigatons before? I meant megatons. Okay, so that's the relation. And when we look into all these flows and compare it, then we can see that the recycling makes up 1.5% and the reuse 0.4%. And when we look into all the flows except for the non-renewable flows, since the socioeconomic cycling is mainly about non-renewable materials, then we can see that we have 1.9% circulated in terms of recycling and 0.5% in terms of reuse. When we look into the interim output side, so you can see here it's 630 megatons roughly, and there we have a bit more on recycling and reuse, since the interim output is of course lower than the processed material. And we end up with 2% and 0.6% for recycling and reuse. And if we look into only the non-renewable flows, we have 2.3 and 0.7%. Of course, this is quite a low number compared to the global average. You can easily imagine that in consumer countries, so countries that have a very low extraction and very high consumption level, it's easier to have higher rates. So that's of course something that is due to South Africa being a mining country and where a lot of materials are associated with mining. And just a second. I have a small screen and I always have to shift around all the elements on my screen. So the fossil fuels plus the extractive waste from coal and metal ores amount to 60% of the processed material and 74% of all flows. and these are quite limited in the option space for recycling and reuse. So that's of course a big burden to the South African economy when it comes to circularity. And when we look into that in more detail on the production side, what are the barriers? Then we find that an economy material dominated by export-oriented extractives. So that's the reason why the circularity is so low. You have a lot of extractives, and everything that becomes, not everything, but a huge share what becomes a good quality metal or a large share of coal is exported. When you look into the economy, you see it's energetically dominated by fossil fuels. So what Harro already said, on the one hand coal, but on the other hand supported by imported oil. And then you have a sizable footprint of bio-based activities with some attention to ecological cycling. So there is ecological cycling, but with also significant concerns. So we haven't done the complete assessment on this one, but we do not assume that a large share of biomass is produced and discarded in a sustainable way. So when we look into non-production circularity potential, we can make something that is not a kind of very plausible picture, but maybe it's helpful for discussions. We can exclude fossil fuels, extractive waste from coal and metal ores, and biomass except for food waste and timber, to have a better understanding what would be the potential there. Of course, it's not realistic because we put out all the energy like coal without replacing it by something else. And of course, it doesn't come for free. So it would have some implications on the material base. So when we do that and exclude these flows, we can see that the circularity is of course much higher. So we have 9.4% of circularity rate on the input side and 35% on the output side. The 9% is something that is an estimate for the global level from different sources. So when we put out these extractive orientated flows, then we come there in South Africa to the same level. And when we compare now South Africa to other countries, other parts, this is the Sankey diagram of South Africa, and we take one from the EU 28 for 2014. I mean, the years do not make such a big difference from one year to the next one. These diagrams do not change too much. And we put them there in the way that they, at least concerning the extraction, are in the same kind of visual representation in size. We can easily see that there's a big difference what goes on to stocks. So in South Africa, we have 15% of domestic extraction that goes on to stocks. In the EU 28, it's 60%. And stocks are the ones that provide services for the people. And this means we can really say South Africa has a very low rate of domestic stock building. When we look, you could say, okay, the extraction is not the right measure to look at. It's better to do it on a per capita base. Even on a per capita base, in the EU 28, we have 8 tons, and in South Africa, we have 2.3 tons. And if we take this one step further and compare to another study that used exactly the same approach as we have done here, it's for China, then we can see that in China, 1995, they used 71% of their stock aid, of domestic extraction for stock aid, and in 2015 it was 87%. Okay, of course, as soon as we want to have a critical view on numbers, China is always good to make a picture look very small. And this is here kind of expression of this. In China in 95 had 6.7 tons added to stocks, and in 2015 it was almost 21 tons, so 10 times more for an economy that was built up as well for exports, but of course less extractive oriented. So when we look at the waste side potential now to circularity, that is the picture from before. So we have the 149 megatons, and we know 11.3 megatons are recycled and reused, and compared to 40 megatons, that's quite something. When we look here into more specific material categories, the picture looks like this. The steel, the end of life waste is about 4 megatons, and there's a quite high recycling rate and a bit of a reuse of metal frames, what we found. The concrete is very challenging in terms of how to recycle it, and we can see here that there's a much smaller amount that has been recycled and a bit of reuse. We have wood here. We can see it's the recycling of paper mainly and the reuse of wood products. We have container glass, quite a successful story where a lot of container glass is reused and a bit is recycled. We have plastics here, so that is not such a big amount that gets recycled, and with plastic recycling we always have the question of how much is it really net energy saving. We have copper here. I think we look into that in more detail in a minute. There's recycling, and it is already a routine. We have lead. Lead is quite simple, since it's not in so many products in high quantities, and the car batteries make up a huge part of it, so there is quite a high recycling rate. Then we have aluminium, and there are good recycling rates, but the numbers are very uncertain, as we have seen in recent discussions. And it's not easy to find better numbers. That's the other story about it. And then we have clay bricks, something that was important to us to look into, because we had an assumption that there is a higher reuse rate, and there is high informal reuse, as we have seen in our kind of estimates. Of course, they need to be challenged, but we assume there is quite a good reuse. Okay, now it comes to copper, and Harro, you take over for this one.
Yeah, so our subtitle said pockets of circularity, and some of the metals, because they're high value, I think we kind of intuitively know have high recycling and reuse numbers in South Africa. So this picture, courtesy of one of our master students, Ongezwa Mbaba, Ongi and her partner Ayanda looked at some of these metal flows for their final year project last year. And what we see here for copper is that we seem to demolish more than we put on stocks. Now there's some uncertainty there, but that's the estimate. 156 million tons, so 156,000 tons of copper being used in 2017, but 191,000 tons coming out from infrastructure. That would be worrying if we're actually stripping down the copper stocks in society. So maybe some uncertainty there. And then what we can see is more of the copper we use is old copper than new copper. So almost 130 kilotons of copper that gets remanufactured, resmelted, re-refined. With the top up from the mining sector only the order of 30,000 tons. Of course, some copper exports as well, and despite this high circularity, we still have a lot of copper being lost to landfill, an estimate of just short of 60,000 tons. So just illustratively, then what one can get when one drills into individual materials, if the data allows that. So yeah, I wanted to show that one, and we have some for the other metals, which I'll discuss under a different topic later. I think it's back to Willi.
Yeah, and when we look into the waste side potentials to circularity and these pockets of high circularity in the domestic economy, there are options what can be improved, and here we can look into certain materials that might be recollected, reused more frequently: textiles, household appliances, electronics. Examples for improvement are, of course, they are from Europe, and I'm not sure how that would work here, but to have resource corners close to shopping centers where people can bring in their stuff or reuse boxes. There are lots of local initiatives around that look into reusing material that could be strengthened in a more systematic way. And one issue that is quite important and interesting is this communal stocks that are so low in South Africa. And on the other hand, we talk about the transition, and we have to scrutinize how big the mining sector will be in future, the coal mining and the metal mining. So the question is, when we phase out certain areas, if we could use that for other areas and for low-cost housing, for example, from secondary material. There was one example in Singapore that is very interesting. I think it is not from the mining sector to housing, but from housing to housing. So they had some old buildings in the city center, and where they used certain materials and had an inflow of certain components like windows or frames and so and panels and so on, and they are all built into stocks. And these stocks were then demolished, and they looked into it. What is the outflow of components and of materials, and what can be done with these materials in order to build new houses? And they had architects who were looking into these components and were designing new houses, and they built their houses on an industrial site in a factory, and these were partly built walls that are already prefabricated, and then they delivered it to certain development areas where this was built into houses. And in such a way, it's possible to look into what do I want to dismantle, to demolish, and to what extent can I really use the components from there in order to build something new and to improve the stocks in a way that they might provide better services for all. Okay, Harro, you.
I get to have the last part of the presentation. A quick look at what we export in relation to the beneficiation discussion, which this forum is very familiar with, and how do we relate that to a transformation towards a circular economy, or to a concept of green reindustrialization, or maybe even green restorative reindustrialization. So Willi, we're going to show 3 slides here for the key metals that are exported. This is for chromite. Again, the work of Ayanda and Ongezwa. We have done a bit of extra work on the numbers they generated, and the diagrams are not 100% accurate at this stage. We getting them redrawn, and we'll include them in our final report. But I think the story is quite clear. So for chromite, we actually have a fair bit of local beneficiation. You can see the export of ferrochrome relative to the chrome ore export in in terms of chromium element is quite favorable. I mean, there's of course still a lot of chromite ore also being exported. And then there's the domestic use, which is much thinner, smaller flows that goes through into ferroalloys, stainless steel and the like. So that's the picture for chromium. Then the picture for manganese is not that good. We export unbeneficiated a lot more, it would seem, unless we overlooked something major there. And then lastly, for iron ore, again, in terms of iron as an element, we see that the exports dominant and the local beneficiation much smaller, and the local steel that we make actually with a pretty decent circularity, and just in terms of the size of the arrows. So, you know, what we're trying to say here is that the work we've done here could also be useful as we engage this beneficiation discussion. And one of the pieces of work that our research group is busy with is looking at using hydrogen made from renewable resources to directly reduce that iron, so that we don't export iron ore, but we would export pig iron, or which is called green iron, and this in this case would be green iron. And there's a significant interest in somehow beneficiating South African solar energy and sending the produce over to Europe. The hydrogen directly is not that easy to move. People want to make ammonia and send it over there as a power fuel, but what about just beneficiating our iron ore? But that still would leave us as an extraction-focused economy providing raw materials to others. And maybe this is the time to then go to our overall findings again, and to just problematize that positioning. So our findings, as Willi has already said them, and this is the conclusion, no surprise here for you. The economy is material dominated by export-oriented extractives. We've just put the numbers to it. And also no surprise that the economy is energetically dominated by fossil fuels. No surprise there. Again, we've just put the numbers together. For me, the biggest surprise in the work as we've done it is finding four. So finding three, the bio-based activities are sizable, maybe not that much of a surprise. And there's work to be done around circularity. But finding four was the one that really surprised me, that how low our rate of domestic stock building is. We know we often talk about there being insufficient investment into infrastructure in this building. We also talk about 40% of the population being left behind, unemployed, not able to consume. So our domestic economy is too small relative to our population. But just how bad that is has come out in this study for me, how low that domestic stock add is. And the fifth finding was that we have already, when we talk circular economy, you already do have pockets of high circularity, and that there's also a significant informal activity that contributes to that. So those are the major findings. And then we just want to take it back into this question of the export orientation in our final slide for this talk, and then we open for questions. Really, the diagram here says what we have and what we might want to aim for, going from a very linear economy to one where the domestic use is much bigger, and maybe the stock add also is much bigger, not just the single flow through. But shifting the attention from the left part, the extractive focused and export focused part, through much more to the whole economy, and then of course onto the domestic economy, where so many of our compatriots don't enjoy the good life yet. And so we would need to shift expertise away from this focus on extraction, mining, processing, refining, towards designing and constructing material loops. Ideally, those would be slow material loops with low impact energy to operate, and low material input for maintenance. And we'd have to shift our mindset in a sort of engineering sciences away from single technical processes towards understanding systems and designing systems, which include production use, post-use, and repurposing through interplay, through multi-stakeholder work, where producing companies, consumers, local governments, producer responsibility organizations, and so on, kind of all design these systems together. So that's the challenge that we leave you with. Thank you very much for listening to us. I think we only have a slide of acknowledgements after that. The funding comes from the DSI Waste RDI roadmap. And we'll do our presentation to the Department of Science and Innovation and its stakeholders at the end of this month. We thank Prof. Linda Godfrey, who has guided us and supported the study, our team members, and also those experts who critiqued our first draft and contributed with suggestions and leads towards the final numbers. They are shown on the right-hand side of this slide. Thank you, Aisha. We are now open for discussion.
Thank you so much for that presentation. It was incredible, and I can see the wealth of information there. And I'm just really glad to have been, to have seen some of that develop. So we have a question here from Mike Woodhall. Export orientation reduces circularity opportunity. Are there any comments on Australia or Chile, for example?
I don't know, Willi, have you worked on the Chilean or Australian economy yet?
Yeah, I have looked at them. I mean, they have a very similar issues. I mean, especially the Australian economy. They're very much export oriented. When we look into the per capita materials they process, that are very high numbers. I mean, there we have this combination of a vast country with low population density that always tends to have a higher kind of material use, because you need a bigger road network and you need a bigger power grid and so on. But of course, there the extractive waste plays an enormous role, and that's on my schedule, so to say, to look with the knowledge now on South Africa more precisely into these countries. And I think that Chile and Australia are very important in that kind of respect. So I cannot tell you more than these very general things.
So, Harro, I see you answered his next question. Would you like to just touch on that? So it speaks to China's high stock numbers because of their import raw materials to feed their manufacturing capability. If South Africa expands manufacturing capability, will the numbers change significantly?
Yeah, so the first part, I must say, I also found it quite interesting to see just how high the stock ad in China has become. Willi, I don't know whether you have a comment on those 21 tons per person per year of stock ad. That's enormous. And I thought that actually kind of built all the infrastructure, but maybe in 2015 they were still busy with lots of roads and belts and roads and bridges and stuff like that. Import and exports in China, I think the physical trade balance is roughly equal. But of course, yeah, they do also supplement their domestic extraction with imports. From our perspective, we always think they import everything, but they don't. And of course, if we manufacture more stuff locally for domestic use, then that wouldn't immediately improve our circularity, but in the longer run, after the stocks have built up and start to be reused, we would start to see the circularity indicators go up.
So last question from Mike. Where are the quick wins for circularity, just from a change of habit at a personal level or at a local or national governmental level?
Yeah.
Quick wins.
Yeah, I mean, it depends very much how you look into it. When we look into it in a very positive way, we could say, I mean, the one big win is when we shift from a production extraction society to a reproduction or restorative economy, it's more labor intensive. So in industrialized processes, we have worked for ages now to make the labor productivity as high as possible. So that means at the end of the day, that with very minimal labor input, we process very high amounts of materials. Yeah. Of course, the labor productivity is measured against money, but at the end of the day, this is the same then for material that we want. We have low labor input but high turnover in material. When we go to the reproduction side, so repairing, reusing, all that kind of things, it's very labor intensive, yeah, and it needs, of course, far less material. So this would be a big gain there. And of course, in terms of another gain would be that the environmental pressure is far lower because the energy input is less, but the labor input is higher. So that would be one big gain. If all these gains are seen by all of the players as big gains, that's of course another question. So we have seen in many different situations that there are big vested interests, especially with the mining sector. Just look at the global oil industry, who have already kind of looked into it, how many dollars of money is lying in the ground, and where they have an option for that. Of course, for them, it's not a quick win when we discuss circularity. And when we discuss climate change and how to get out of the fossil age. So it depends a lot, but I think it's a big shift from big enterprises to small and medium enterprises. It's a big shift for local labor demand, and that would help a lot to improve the situation of many people. Yeah, I think these are the main gains. Economically, of course, it's not just such a big gain, but if it's an economic gain or not does not only depend on the economic activity. It depends on our ground rules set out in our economy, and the economy is now built in a way that everything that can be externalized, all environmental pressures, are for free. So as soon as we would start changing this in a fundamental way, I think it could be even an economic gain, a big economic gain.
We have a question here. In general, would a more circular economy with higher stock building translate into better environmental outcomes?
Oh, from my side, Willi, I like to say that to get a low impact circular economy, you need low impact energy to make materials go around and round. So yes, of course, by not dissipating the materials after use into the environment, and we know the extraction and refining is energy intensive and materials intensive, we get gains, but we also pay attention to what form the energy is that we use to make the materials go around. They get transported by old 3-ton trucks in town that belch out diesel smoke and fumes, so there are environmental impacts if the energy is dirty. But yeah, in principle, more recycling, most studies I've seen show will reduce impacts very significantly. That's a very generalizable finding from the world of life cycle assessment.
I mean, what maybe just this other perspective, one of the key issues here is if you have in terms of stocks, a kind of stabilized stock or a largely growing stock. Yeah. What we have seen, for example, in China, you cannot have any circularity with these fast growing stocks because everything that is demolished is a result of what has been built 10 years before, for example. Yeah. So 10 years before, they haven't built a lot. So there is very little material that comes out of old stocks, but the demand for building new stocks is huge. Yeah. And so I have done just for the global metal situation worldwide, I have done an estimate, and if we would recycle all the metals 100%, yeah, we could only satisfy 50% of we need for stock building now, yeah. So that's the biggest issue. What kind of stocks do we build? Where do we saturate it? I mean, South Africa is very low in stocks, but just to increase it indefinitely, that's not the issue. So where is the right level of saturation of stocks that have a kind of balanced service to all? So that's another question. How just is the distribution of services and so to say of stocks? So these are the issues, but of course you can manage stocks in a steady state economy quite well, as long as Harro said, the energy is renewable, the stocks are slim stocks that are low in maintenance. Just this example, when you use a transport system based on rails and one on road, there's a big difference on what kind of maintenance materials you need. Yeah, I think it was a factor 5 or something like that per ton kilometer of transport of people and freight. So there are big differences, yeah, in that. And so it is a question: what kind of stocks do you build? How are they in terms of material intensity for the service, and what do they need for operating them?
So we have one last question, and then we're going to close off the session from Willem Nel. I think the situation in a country normally changes slowly over time, perhaps best measured in decades. How is the impact of the energy transition from fossil fuels to more solar farm, wind farm, battery, and electrical vehicle mineral flows likely to change the situation for a country like South Africa and Germany?
Yeah, I mean, on the simplistic side, as that transition happens, on the inflow side, the orange bar disappears with its little red bar, and then the circularity indicator looks better. And I think in countries that are a long way down, I think Germany's now reached 50% of its electricity supply from renewables. The amount of material flowing through, from extraction through the energy side of the diagram in a one-way street just starts to shrink. That's the simplistic answer. I think the point we got on our final conclusion slide, that this shift from a focus on processing in the extractives, which has dominated our engineering education, and the job opportunities for mechanical, chemical, civil, electrical engineers for a long time. That's the decadal shift we're referring to, getting people to work more in working in the built environment rather than in the mining sector. And of course it needs a smart understanding of the types of materials that they'll be using, secondary materials where available, and primary materials to build the type of nice built environments in which we all want to live. So I think that's a big challenge to us. And if I may kind of use this to respond to the comment by my colleague Henry Mostert. Yes, the big picture tells us the obvious there, and yes, Henry, when we drill into the detail, that's where the value to researchers like yourselves hopefully are. That picture that's there on copper, courtesy of Ongezwa, I think that validates why you and your team are still working on e-waste, even though most of the copper we use already is old copper, is recycled copper, but we're still losing too much of it. And so how do we start to shift the regulatory environment so that product designers start to have a responsibility that the copper that goes into electronics actually can come out in the end, because oftentimes metallurgists just can't get it out because it's been designed into products that are not, you can't get it back. And sometimes it needs innovations coming out of our laboratories here that get that copper with microbes or other new technologies. And that's research also funded by the DSI roadmap. And it's not my research, to give credit to my colleagues here in the department, the Minerals to Metals chair, Johan Peterson, my DVC, Prof. Sue Harrison, they've kind of explored these things and together in an interdisciplinary way with people in law like Henry Mostert and of course Aisha, who's doing a PhD on this kind of regulatory question. So we're all in this together. Thank you very much.
Yeah, maybe just this one thought. Maybe it's unfair to have this at the end, this fundamental thought, but we're talking here about the transition that changes everything as we know it from the past. Yeah, I mean, the industrialization process is now going on for hundreds of years, and we only know that kind of growing economies where everything is growing. The money is growing, the turnover of material and energy is growing. And now we talk about something where this needs to be changed in a fundamental way. And I can't see a way that this is done in a planned, incremental, smooth process. Yeah. So I'm quite sure there are a lot of disruption on this way. It's so fundamental. Yeah. And just to put it now on a very practical level, I mean, I think there are other more complicated levels that might interfere, but on a very practical level, when we change our whole energy sector to renewables, the flows, the inflows are much lower in terms of the operation, but the stocks we have to build is a huge amount of stocks per megawatt hour. It's far more stocks we need in renewable energy plants. That we know that fossil energy plants need a lot of fossils, but the plants are very do not need a lot of material. But the new ones need a lot of material, and there will be a huge competition worldwide for that. And there might be scarce materials. There might be stronger economies that secure certain kind of access to material while others don't have it. So I think this will be a huge struggle. And so in my view, it will be quite decisive on a global level and on a country level, not just to think about it. We use a lot of energy and now it's coming from fossil fuels and in future it comes from renewables. I think this will not work. I think we need to build really robust economies that can do with much lower energy levels. Yeah, and I think this will be a big challenge, and I think economies are not prepared for that, and that's why I think there will be a lot of conflicts, competition, and difficult situations at all levels. Yeah, that is not a very nice answer to that, but looking into these kind of material dynamics on a worldwide level for hundreds of years, I can't see that it runs smoothly.
We could use it as a call for action and try and use the research that you've provided us to step forward. And yeah, as you say, call to action for me and Henry to speak more thoroughly on our topics. So thank you so much for the session. I really appreciate it. And I'm sure I share sentiments. Everyone in the chat has said excellent presentation. So thank you so much. And I hope everyone has a lovely Wednesday afternoon further.
Thank you so much as well.